This is the Cavendish Laboratory at Cambridge University, where the constituents of the atom were first discovered, the realm of the very small. From the time of Democritus in the 5th century BC, people have speculated about the existence of atoms. For the last few hundred years, there have been persuasive but indirect arguments that all matter is made of atoms. But only in our time have we actually been able to see them. Here, the red blobs are the random throbbing motions of uranium atoms, magnified 100 million times. How Democritus of Abdera would have enjoyed this movie. We pretty much take atoms for granted. And yet, there are so many different kinds, lovely and useful at the same time. Look. There are some 92 chemically distinct kinds of atoms naturally found on Earth. They're called the chemical elements. Virtually everything we see and know, all the beauty of the natural world, is made of these few kinds of atoms arranged in harmonious chemical patterns. Here we've represented all 92 of them. At room temperature, many of them are solids, a few are gases, and 2 of them, bromine and mercury, are liquids. They're arranged in order of complexity. Hydrogen, the simplest element, is element number 1, and uranium, the most complex, is element 92. Some elements are very familiar. For example, silicon, oxygen, magnesium, aluminum, iron, the elements that make up the Earth. Or hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, the elements that are essential for life. Other elements are spectacularly unfamiliar. For example, hafnium, erbium, diprosium, praseodymium, elements we're not in the habit of bumping into in everyday life. By and large, the more familiar an element is, the more abundant it is. There's a great deal of iron on the Earth, not all that much yttrium. The fact that atoms are composed of only 3 kinds of elementary particles, protons, neutrons, and electrons, is a comparatively recent finding. The neutron was not discovered until 1932, and it, like the electron and the proton, were discovered here at Cambridge University. Modern physics and chemistry have reduced the complexity of the sensible world to an astonishing simplicity. 3 units put together in different patterns make essentially everything.